When I was starting to learn how to use Creo, someone told me if I can model this fan. I thought it is straightforward. I thought it is simple, but it needed a lot of experience to understand how to model it. It's not simple. I initially thought simple, but it is a more advanced. Let me explain why, and I'm going to show you how to model this one here. There are so many methods there in YouTube on how to model this blade, but I'm going to show you the most recommended technique to use. Let's first of all analyze this geometry here. If I view from top, you can see this fan, this blade has a twist. You can see this one. This means it has a twist. Okay. If I view from this side, you see the twist I'm talking about. Okay. Then let me first of all suppress radii. It has a twist. Then if I view from this side, the fan, you can see the twist I'm talking about. It has a twist. Therefore, it has a 3D twist. And it is, for me not to understand how to create this, it took me some time to understand the technique properly. I'm going to explain the technique to you. Then, if you view from this side, you can see the cross section. If I cut a section here, as you go this direction, the cross section is increasing. Therefore, I'll show you how to model this. Let's start a new part. It is very quick to model the central section. That's an extrude boss there. I can use maybe 100. I can say maybe 60. It doesn't matter. I'm going to use surfacing. For me, I'm a very fan of surfacing. Yeah, make it 25. Yes. Okay, now we're going to use sweep here. We're going to start from how we know from the basic sweep, and then I show you how you can now go to the next level to twist it. When you're creating a sweep, the first thing you need is a trajectory. Therefore, here, the reason why I said be symmetric is because I want to create my sweep onto this plane. For me, I like symmetry a lot. Whenever I design anything, I like to maintain symmetry if possible. And I want to define my blade length as maybe 150, and I want this length here to be a little bit. I want it to be interfere with this surface a little bit, so that once I merge, I'll be sure that the surface here and this they are interfering for them to merge to each other properly. You can give it name there. Then we select this one here and say sweep. We're using a surface sketch. I'm going to drop some center lines. I'm a very fan of center lines, by the way. I like using center lines where possible, especially when I'm using line. That is the profile. When you view from this side, that is a profile. And I want now to dimension, to drop some dimensions here. Let's say the initial cross section to be 20 and 20. Yeah. And let me drop a center line at this point, so that I can define this orientation using this center line. Then let me drop this argo here. Let me just delete this. Let me first drop my center line first, then drop my spline later, like that. This will be 25. Then my spline here to be give it some dimension. Here to this one here. I want to select my delete it for dimension here for ease of selection. 25 here. Give it 120. Then drop my center line at this point, somewhere there, give it 25, and this center line here, coincident, yeah, predefined. Why are you having this? Okay, my center line should pass through the center. Delete the dimension, yeah, delete it. Yeah, sometimes getting a predefined sketch in Creo can be not straightforward. You have to understand your design and see if it's functioning. I want this to change. Yeah, rotate. Yeah, perfect. Why have I used this method here? You might ask yourself why. It's because I want to remember we saw that this profile, as you move across the cross section, it is twisting, and this is the value you're going to change. You're going to say at the start be 20, but as you move through the profile, through the cross section, change. But for now, you're going to leave it at 20 to prove a point to you, like that, and have a surface. Let me just give it some appearance here. You see my surface? If I view from this side here, like that, it has a uniform cross section. You can see. But remember the one we saw, it was twisting. And I said, for us to be able to twist this cross section here, the angle we need to change. Let me use D instead. This is a value you need to change. If I change this from 20 maybe to 30, see now, it is rotating all the surface. What I want is, this is what I want. At this point, to be 20, but as I move across, at the end to be 30. If I can achieve that, this one will twist from 20 to 30. And this now, the method I'm going to illustrate today is the advanced method. That took me some time to understand. I'm going to create a graph, call it angle twist, angle change. You're going to change that angle. I want to describe what is a graph. If you want to understand in detail when to use graph, how to use it, let me know. Comment section. I'm going to change that angle. Just drop another center line here. This to be 100 from each other. And I'm going to change the angle from 20 to 30. I'm going to use a spline like that. Change from 0 to 30. Start with 20. That is what we need. From 20, as you move, this means as you move across this direction, change from 20 to 30. Say okay. If I move this data up there, if I go back to my cross section here and I go to sketch, and there's what we call relations, and I can use a relation. I can say, can you change this argo SD 15? Also, you can give the name, you can give these dimensions a name. Also, let me show you how to do it first. Let me first show you how to do that. Here you can say, if you double click here, this D, you can say Ago. Okay, now if you go back now to actual sweep, sketch, go to tools, relations there. Okay, it is still D5. Okay, I'll show you later how to do it. Yeah, this one is a sketch. Yeah, it shouldn't change, but it is okay as long as you understand what you want to change. It is SD15 equals to, we are going to say evaluate graph. Evaluate graph. Make sure you collect your spelling is okay. Evaluate what graph? Which graph? Called aggregate. From where? When you say from 0 to 100, we say we use the word Trajpar. This means from 0 to 100% Trajpar of what? Of the 100. If you say now, relation has an error, okay, to put what? To put, okay, I see. Apologies, I see my mistake. It is here. You say SD15 equals evaluate graph. Which graph? Page. Yeah, it should be like that. Evaluate graph. Which graph? You put a bracket here. Page. Yeah. Now, you see, it is now 20. If you go back here, you see, okay, nothing happens. But you saw that the sketch, let's just use D instead. You saw that the sketch now went to 20. This one is 20. Because in a graph, we said starting point to be 20. It's 20 here. We are not getting 30. Now for me to figure out why, it also took me some time. Now, as you can see now, this cross-section is constant. But when you start to change cross-section, just need to press one button here called variable cross-section. Just that. You can see if you select that, that is twisted. Because it is going to change, it is going to vary, it's going to twist. If I go now to this view, you see now we have a twist, the twist we are looking at. And if you sketch onto this plane, if you're curious and to sketch here, if you say take this point maybe, and also this point here, and draw a center line from here, that point, this angle, let's see, should be 30. This is the angle we defined to be the final angle. Therefore, to be the final angle to be 30, you can see this 30. If you change the value of the angle change, maybe from 30 to 50, this is going to change. Okay, even you can test it. Then go back here and change this from maybe I want the final angle to be 35. Say okay. You see, it has changed. You can see now you have 35. Let me undo. Don't need to use for illustration like that. Step 1 done. Step 2 was now to vary. If you're going to vary, so go like this. That's how the blade looks like. You see? How can you now capture this? As you move across this direction here, the cross section here is changing, and we need to capture that as well. Let's go back to my sweep and see which dimension we need to change. We just need to change this 20 and this 20. And we're going to use similar technique I've illustrated, changing those two. If I go to datum now, I can say maybe Z1, again drop a coordinate there, drop a center line, help you to, it's not a must, but help you dimension. Now I can say 100. Start, line, and I'm going to say start by 20, finish by maybe 25, like that. But I want it to change. I don't want it to increase in a linear way. I want it to increase like this by what? 120, start with a 120, but finish with maybe 130. Yeah, I can say finish with yeah, let's go maybe 100. I want it to change. See the rate of change. That's the rate of change. Take one. You copy, paste. Okay, you can and call it edit and change from 20 maybe to 50. It can also reduce to be 90 and maybe just to be 120 maybe, yeah, like that. Side 2. I just go back to my sweep here, sketch, go to tools, relations here. I just need to copy this twice, paste it on here, and you call it SD3. SD3 equals to evaluate side 1, side 1, copy, paste, and use SD4 to be my side 2, like that. Yeah, no error. Now you can see we are starting at 20. If I go and say okay, you can see now the bread starts to increase, and you can see there's something I want to see. You see the graph we defined. You see there, what we defined here is what we get. You see how we defined this to change on my side 2. Just take a screenshot of side 2. You see exactly. Let's see exactly. Yeah, I can see they are same. You see this one here, it says the same as this. If you want this to be straight, this will be straight. Yeah, let's go back to side 2 and change. We're going to change that profile from maybe from that. Maybe I can say a line there and replace with this. Yes, this is just for illustration. You can see we are getting a straight line, because now my side 2 graph is also a straight line. Therefore, if you want to be more, want not to try your software to see, you can change like that. You see, get it. Whatever you define is what you get. See, yeah. Therefore, you can now define this cross section in that graph. Whatever you define is what you get. Sometimes maybe you want to design something and you want to have a certain type of cross section as you move along the length. Next is now the last step here. You need to trim this. Therefore, I'm going to say to project a sketch or to define onto this plane here. Sketch like that. I'm going to use a circle of maybe can see project this one here as well. Reference detergent there. See, okay, because I need to remove this surface using this face. I want to project there because I want to trim this using this curve the other side like that. Okay, you can see we are getting our blade there. You can now maybe offset this by thickness of your blade. Change the electron, the thickness is 2 mm. Options, left side surface, that, merge, that, 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 around here, that, not around there, a new set, maybe a round of 2. No, don't need a new set here, delete, because you need to merge this first. Merge this to this. Level the electron, like that. Move round, move merge above, then change round. Then come edit round to add a new set of 2 or 3. Add this one here and this one here. That you can see. I can also let's do all the round once. Do another new set. Remove onto this edge. Maybe 2. Let's bring this for you to see that it's possible to do some round in the surface itself. Okay, it seems we can't round off here. This is too close. This one here, and this will go up with 5. Something more. Okay. Alright, let's just delete this one here. It's because here. Okay. Let's make it 1. Anyway, therefore, I usually advise people do not pattern the surface here. Some people are tempted to pattern this quilt, you can say. Go here on this quilt, you can be tempted to pattern, do an axis like that. Angular, say okay, can do that. Also, you can merge. Usually, see, there's a lot of steps. You have to merge all of them at once. I don't like, for me, I don't like pattern a surface, merge everything. I like solidify it first, then pattern the solid itself. Then pattern the solid itself to reduce those steps. I know we are going to get 3 bodies because when you go to options here, there's no way we can say bodies to merge. I've not seen it. Maybe Creo need to have that improvement whereby when you say pattern bodies, you can have an option for these bodies to merge automatically. Therefore, because now I'm getting 3 bodies, now I have to select all of them and merge them. Okay. Now I have that one body there, one body. Yeah, that's my blade. View and check reappearances. Yeah, I have seen it is complex. It is not straightforward. Yeah, that's the beauty. That's the beauty of engineering. You get something complex and you push yourself to the limit to understand how to do it. It took me a lot of time to figure out, although I had some references online. Yeah, try on your side. Make sure you understand how to use graph first. You have to understand how to use one. See, how to use sweep, two, how to use Trajpar, 3, and how to use graphs. It is a combination of three things, and you have seen that sweep variable is very advanced. I have used a sweep. I go back here. I've used a sweep and I've used normal to trajectory. You have to understand the sweep properly to understand how to use this. Because if you select maybe normal to projection, maybe say, yes, to this projection, you see, you're getting a different, you see how you're getting it, how looks similar, but not is rotated 90 degrees. Therefore, it is not a straightforward thing, but it's a very good exercise for you to learn how to use advanced tools in Creo. Let me know in the comment if you have understood how to model it. If I was very fast, I can create another video whereby I can go a little bit more slower, go in explaining to detail of everything. If you want, let me know in the comments, and thank you.